So, in this video I'll be looking at drawing ray diagrams. This is all to do with lenses and telescopes, but we need to be able to draw some, interpret and use these diagrams. Now this slide, as an opening slide, is meant to be confusing and overwhelming, but this really isn't that complicated a topic. This is what most people will think when they see this. They'll think this is tough, this is difficult, what on earth is going on? But I'm going to really break it down, make it as simple as we possibly can, and by the end of it, it's going to be quite manageable. And this is really an area where if you get a good knowledge of this, you will do well where lots of other people struggle in other schools. Okay, in our last lesson we looked at this sort of thing. This is a convex lens, and we looked at the idea that as light approaches a lens, it can change direction and travel through with some sort of change. Or yeah, this is what lenses do. They focus light. I also showed you this slide, which shows how these. So we've got these straight line wave fronts coming through like this and being directed, but we also sometimes use light rays which show light travelling in a straight line from one point to another. So this wave front idea is useful for us for understanding refraction, but actually in the practicality in terms of how to draw ray diagrams, we are now going to use light rays. So it's switching over a little bit, but that's something we're going to do. This is me, and this is my eye. And you can see why I'm a scientist and not an artist. Come on, pen. Okay, that's me and that's my eye, and I'm going to try and have a look at this car. Okay, why can I see the car? Because it's a nice sunny day, and light from the sun travels down into my eye, and it goes like this. There's light coming from the top of the car, this travels in straight lines, bounces into my eyes, and I see that. There's light coming from the bottom of the car, there's light coming from the middle of the car, there's light coming from the wheels, there's light coming from all parts of the car, and my brain and my eyes together managed to simplify this situation and managed to let me see and understand what's going on with this car. So the image of a car is made up of 1,000 or maybe even 1,000,000 individual light rays all arriving in my eye, and my eye being clever enough, in inverted commas, or sophisticated enough to work out what all those bits mean when you put them all together. In terms of, well, we're going to try and make our lives a little bit easier when we're drawing ray diagrams. Instead of complicating a thing by having all those lines in there, which just makes it impractical, we're just going to do a couple of lines to show the journey of it. We can do one line from the top of an object and another line from the bottom of the object, and these lines here coming into the eye, that shows here what we've got. It's sort of assumed here that we're able to see all these parts of the car in between. There's no point me filling this all in. If I put in these two lines like this, it shows that I can see this entire image. And when we do ray diagrams, we do a very similar thing. And remember, there's two types of lenses. We really are going to be concentrating on the convex lens and looking at those because they're the ones that we deal with more often. When the light actually arrives at our lens, the way that we're going to draw it, instead of drawing the detail to show how it actually is reflected as the light goes through, we do this approximation where we draw a dotted line through the middle of the lens, and we imagine that the light goes straight up to the center of the lens and then is refracted. Goes straight up to the lens and then is refracted through. Okay, so for drawing these, this is what we do. A few rules that we use for drawing a ray diagram, our ray diagrams, okay? And there are three sort of magic rules that we're going to look at, and we just need to remember these three magic rules, and then we can draw any lens in any situation, and it's just a case of applying these rules to see how they work. Alright, so I'm going to draw a tree here, and using all of my artistic skills, this is my tree. Okay, and I am going to basically look at how light from this tree can travel through my convex lens and see what happens to it when it goes to the other side. Okay, now before we begin with this tree sending its light through, just a little bit of terminology. This line running straight through the middle here, we are going to call the principal axis. So it's an axis because it's a straight line and it runs straight through the middle. It is the principal axis. Okay, so here are our rules. So rule number one is that if you've got a parallel array that's parallel to the axis on the way in, then it goes through the focal point on the other side. So array here parallel to the principal axis. Now I'm doing this freehand, you will do this with a ruler. Once it hits this line straight through the middle, it is going to be deflected straight through this focal point. So it goes through there and continues on the other side. This is rule number one. Number two. Array through the center of the lens. So array through the very central point from the lens, it goes straight through with no change of direction. So this is the point I'm talking about here, the very center of the lens. So an object from here moving in a straight line through the center of this lens will continue to move in a straight line. So forgive me here, I'm doing this without a ruler, this is freehand. Straight here goes straight through. And rule number three. Array through the focus or the focal point on the left hand side, it is refracted so that it turns parallel to the axis on the right hand side. So a point here that goes through this focal point here, this focus point, will come out parallel on the other side. So again, doing my straight line. And again, forgive me for not using a ruler, but I can't. It's physically impossible on the computer. It hits this line, it is now going to come straight through here. And we now can see exactly where the image forms because it is the point where all three lines meet. And this is where my image of the tree would form. And with all of these questions, any question that you encounter for a lens ray drawing type situation, you need to follow rules 1, 2, 3. 1, if it goes parallel, then it goes through the focus. 2, if it goes straight, it goes straight. Or actually, if it goes straight through the center, it continues straight through the center. And 3, if it goes through the focus point on the beforehand, then it goes parallel afterwards. Now this focal distance here is the same on either side. This is the focal length of the lens, which is just the distance from the lens, and so they're equidistant here, f and f. And it really is a simple case of applying these three rules to draw our diagrams of these. Oh, look who's just shown up. There is a question for you here. What do we notice about the image that has been formed? What can we say about the image that has been formed in this case? Well, look, we started off with a tree, and this light that's passed through the lens here, this image is upside down, or scientific word for saying upside down, the image is inverted. And actually also here we can see that this image that has formed here is, not only is it upside down, it's not been magnified. It's not bigger, it's actually diminished. So it is possible with lenses to form smaller, diminished, smaller image, and you guys will have seen that. Everybody who's made a pinhole camera will have made a diminished image. Or if you hold up a lens near a wall, so if you get a lens and hold it a few centimeters away from the wall, you can sometimes form an image of an upside down window, and obviously the image that you just projected onto the wall there is much smaller than the window itself was. This is also what we call a real image. Why do we call it a real image? Because if I put a film here or a sheet of paper right here, I could physically project that image onto that wall or onto that paper. If you put your eye, or you put something there, then that image forms in space at this point. So we can actually make a real image there at that stage. Okay, so this next section of the video is going to follow the following format. I am going to put up a series of lenses, and what I'd like you to do, or what you're welcome to do, is to stop the video, to take down a quick sketch of the lens and the setup, and to try to replicate where you think the image is going to be formed. You can watch it through once and then go back and try it again for yourselves, or you can try it straight off and then wait and I'll show you the answers. So this was going to be question 1, and what I want you to do is to follow the 3 magic rules for this image and see where the thing would turn up. If you can't remember the 3 magic rules, go back in the video and check them out. So this is question 1. Question 2. Now the reason I've got different F's here, it's just so that we've got a measurement on the system here, or scale, so that when we look at our answers in a little while we can see where we should have got them. Question 3. I don't need to pause long really, because you can pause your own videos. Question 4 is here, and for each case I want you to draw what sort of image you get. Question 5. And question 6 is a tricky one, but you can give it a go if you want. See what's this. Yeah, this is a tough one, and probably not something we're going to encounter actually on our exam questions, but give it a go anyway. Alright, so question 1 I am not actually going to go through with you again, because it is the exact same situation that we already encountered from before. So we've got a large object just outside of this 2F mark, and we should get a smaller object formed in around this zone. In fact, what I'll do is okay, I'll show you a quick cheat here. This is one I made earlier. We've got the one that goes parallel, hits the central axis of the lens and then goes through the focus, and the line that goes straight through the center of the lens carries on straight through, and we get this image here. It is real, it is inverted, and it is diminished. It's slightly smaller. Okay, object number 2, I'm actually going to do this one with you, and again, sound like a bit of a broken record, don't I? But I'm not using a ruler, so you have to forgive me a little bit. So this one's going to go here, and then once it hits there, the rule is that it goes through F, so it's bang on the diagonal here, like so, and this line is going to go straight through the center there, and continuing on, you should find that that is pretty much symmetrical. It goes smack bang through that. I can already see where the point's going to be, but just for good measure I'm going to apply my third rule, that the line going through the focal point on the first hand side comes out parallel. Oh yeah, it's obvious where that one's going to be now. Hopefully we've got our tree coming out at the same distance, actually, to F. So this is a real image, it is inverted, and it's not magnified. It's the same, not magnified or diminished, same size. Okay, but all I'm doing is applying rules 1, 2, 3. That's what I'm going to continue doing. Rules 1, 2 and 3. Dotted line up to the central axis will pass through the focus, and on like that. A line through the center. Actually, you know what? Because I'm not using the ruler, this one is actually a bit easier for me to do first. That was poor, wasn't it? So it doesn't matter that I'm taking a while here. You can, if you want to skip ahead slightly in the video and see the end answer, please feel free. And I also want to point out at this stage that these aren't standard results that you're expected to remember at all. These are just some questions and practice for us drawing these, because you may have to. And we've actually now got these three arriving in space all at the same point, and we find a real inverted, because it's upside down still, but now it is magnified. This one is bigger than our original image. Wahey. Okay, next one is, this one might have stumped you, and you might have, yeah, this is a bit of a strange result, but let's have a look. Again, all we've got to follow the same rules. Image parallel goes through the focus, and this one goes straight through the center. That's weird. These lines look like they're never going to meet each other. What about if we've got one coming through the focus? Oh no, a line from here, a point from here can't go through the focus because it's at the focus. You see, I was about to make a mistake there and start drawing a line from the bottom, but obviously in each case we're doing the lines from the same point, so that I can't get a point from here to go through the focus, because that just goes straight down, so it doesn't actually come through that one. Right, you following me there? So rule 3 can't be applied in this situation because it's at the focus. And you're absolutely right. If you've got this, we get two parallel lines here that never meet, so there is no image formed here. These lines will carry on to infinity, so we don't actually get an image formed at all. Or maybe you would at infinity. Well, you definitely would at infinity, but that's a mathematical discussion for another time. Okay, situation number 5 is a strange one, and some of you may not like this, but tough. Alright. dotted line, parallel, goes down where? Goes down through the focus. And the line from here also goes down through the focus. Now these lines look like they're actually separating out from each other. We've got an increasing gap as we go along here. But what happens in this situation is a strange phenomenon that you wouldn't have gotten. But if I carry the lines going on back in this direction, we see that they actually form up here. And we would get a virtual image, which is not real. This is not real. A virtual image which is magnified, and it's the right way up. So it's not inverted. This is a magnifying glass situation. When you hold a magnifying glass up to a close object, it looks like it is a big object, but you can't project that image, and you have to look through the lens to see that big image, but you can't project that image onto a wall. You can't record that image directly. This is a virtual image of a magnifying glass, and we'd have to put our eye here. This would be a nice eye, there's the pupil, and look through the magnifying glass here, and then you would see this virtual image formed in this way. Now you probably wouldn't have got this question correct, but it was still worth having a go at it, and it's still, these rules do apply. Last situation here, and again, apologies, this is a bit of a nasty one, but you know, it's all good fun. Now this is a concave lens, a diverging lens, and what's going to happen here is something a bit tricky up at that point there. It's true that the line through the middle carries on like so, but because it's a diverging lens, rather than it converging in towards this focus, it would actually diverge out away from that focus in such a way that it would pass through this point here, and again we'd get a virtual image formed here. Now this concave thing, the way that this bounces in like this, we will encounter later. We'll see this in concave mirrors later, but for now, this image situation, we've got one line that goes straight through the middle, one line which would be diverged away from the axis, but it is a case that we do get a virtual image forming here. This is not on your exam. And if you want to be annoyed with me for putting it in here, you have every right to be annoyed with me. Okay, now as an additional extra, I've got one more problem for you, and this problem we'll call number 7. And this is a little bit different from the format of the other ones, but here what I'm looking for is, we've got some parallel rays coming in here. Where will they be focused to? And we're looking for a point, a focal point, that these rays would be focused upon. So if you want to have a go at applying our 3 rules and sticking them through here, I'm sure our friends here would be very happy to see how you get on. Okay, I'm going to now work through this problem as well. Now we've got parallel lines coming in. We're still going to try and apply our same 3 rules if we can. So rule number 1, that's when we've got a line that's parallel to the principal axis, and then we have to but we don't have that actually. We straight away I can see I do not have any light coming in that is parallel to the principal axis, so I can't apply rule 1 here. How about rule 2? Rule 2 is that if I've got some light that's going straight through the center, then it carries on straight through the center on the other side, and I do have that, so I can continue the journey of that light ray. Again, apologies about my ruler, or lack thereof. Rule 3 is if I've got something coming through the focus on the left hand side, then it comes out parallel on the other side. Although the diagram only shows these beams coming in at this angle, there would still be light coming in from all of these directions as well, in the same direction, coming down like that, and there would be light coming through in this same direction through this point, oh dear, here as well. Nice straight line, of course, that you guys would be drawing with your rulers. Now once on the other side, that is going to come straight through here, and using my ruler I should get the point here. Now I know for this answer, if I had been using a ruler, they should be meeting exactly here at the focus. And then if I were to, where I see where these two lines cross, draw in the other lines as well to complete where they come from. And so we get a focus here at the focal length. So light that's coming in from distant objects, parallel beams, will be focused here at the focus. And this is how we go about this process. We're still applying these same rules, but we've just got to be wary or aware that we can add in this extra detail for ourselves.
Now it's time for our wrap-up. Let's give it everything we've got. Ready? Begin.
We're now at a stage where we can wrap it up, and let's simplify the situation. Drawing ray diagrams, this is what we do. We've got a ray that's parallel and then gets passed through the focus, a ray that goes straight through the center, and a ray that goes through the focus and then comes out parallel on the other side. And we need to draw them consistently. We also need to make sure that we're judging things by this line that runs down the center of our lens, and this line here, which in this diagram that I've just picked up off the internet is called OA, we call this the principal axis, or principal axis. And that's drawing ray diagrams, and I suggest you get a good bit of practice doing it, and if you need a bit more practice, go back and re-watch this video and try them again. And next we'll be looking at how to combine two lenses to form a telescope.